The objectives for this video are to conduct a hypothesis test for the difference between two means for independent samples where the population standard deviations are unknown. In 1992, a study was done to determine whether 98.6 degrees Fahrenheit is an accurate mean body temperature for adults. Listed below are the measures for the 65 men in the study and the measures for the 65 women. Test at a 0.05 level of significance the claim that adult men and adult women have the same mean body temperature. We will let the men represent group number 1 and the women represent group number 2. There are assumptions that must be satisfied when testing for the difference between means when the population standard deviations are unknown. 1. The samples are random samples. 2. The sample data are independent of one another. 3. When the sample sizes are less than 30, the populations must be normally or approximately normally distributed. Step 1 is to state the hypotheses and identify the claim. The claim is that adult men and adult women have the same mean body temperature. Remember that the null hypothesis always contains the equals sign. The claim is that the body temperatures for men and women are equal. So, in this case, the claim belongs in the null hypothesis. The alternative hypothesis, then, will be that the means are not equal. Step 2 is to find the critical values. Since the population standard deviations are unknown, we will use the t-distribution for our critical values. Note that the third line of the t-distribution table should be used for two-tailed tests. We should travel across to the column that is headed 0.05 since this is the specified significance level for this problem. The number of degrees of freedom will be one less than the smaller sample size. Since both samples contain 65 subjects, the number of degrees of freedom will be 64. This t-table does not contain a row for 64 degrees of freedom. So we should use the line for the next smallest listed value, which would be 60 degrees of freedom. This row and the two-tail 0.05 column meet at the critical value 2.000. So the critical values are plus or minus 2.000 when alpha is 0.05 and we have 64 degrees of freedom. Step 3 is to compute the test value. In the formula for the test value, we will find the differences between the sample means and the differences between the hypothesized means and subtract them. We will divide that quantity by the square root of the sum of the variance for group 1 divided by the sample size for group 1 and the variance for group 2 divided by the sample size for group 2. Substituting these values into the formula, we see that the difference in the hypothesized means is 0. It is important to understand in the null hypothesis that if the population means are assumed equal, then their difference would be 0. Evaluating this formula, we find a t-test value of negative 2.295. Step 4 is to make the decision to reject or not reject the null hypothesis. It is always a good idea to visualize the orientation of the critical values and the test value by placing them on a graph of the hypothesized distribution. We have a normally shaped sampling distribution, and we are assuming that the population means are equal. If the test value lands between the critical values in a two-tailed test, we do not reject the null hypothesis. In this problem, we are to test a 0.05 level of significance, so we split that value, also known as alpha, into the two tails. That would leave 95% of the sampling distribution between the critical values, and therefore it would be very unlikely that we would commit a type 1 error, which is to reject a true null hypothesis. But our calculated t-test value is negative 2.295. The interval between our critical values negative 2.000 and positive 2.000 defines the region where we would not reject the null hypothesis. Since this test value is outside of that interval, our decision should be to reject the null hypothesis. Step 5 is to summarize the results. Since we decided to reject the null hypothesis, our conclusion is that there is enough evidence to reject the claim that adult men and adult women have the same mean body temperature. In this video, we learned how to conduct a hypothesis test for the difference between two means for independent samples where the population standard deviations are unknown.